Hey everyone, I'm Ben Grimico from InterNACHI. That's the International Association of Certified Home Inspectors. And today we have a really good webinar. All of our webinars are free and online, open to everyone. You may be attending them. You may be attending this webinar live, and it's interactive, so you can ask questions if you want to. And sometimes I'll do the presentation, and sometimes we'll have a special guest. Today we have Bill Schwan from Infrared Training Center. That's a division of FLIR. And FLIR is a fantastic company. They make really great infrared cameras, obviously, and a bunch of other things. And Bill's gonna be talking about some infrared inspection tips for home inspectors. Personally, I think infrared, I've been using the infrared camera since, I can't remember the last time. I got an infrared camera like 15 years ago for many thousands of dollars. It was crazy. But now, well, one of my favorite infrared cameras is the FLIR C2. There are many to choose from. And you can get, for a low investment, you can get an infrared camera. And for me, an infrared camera for a home inspector is like a flashlight. It just helps you do a better inspection. The problem is that you have to interpret what you're looking at. And if you don't know what you're looking at, you're going to screw up everything. So you have to get trained and certified. And one of the best training resources is ITC. And Bill, are you with us?
Yes, I am. Good morning, everyone, or good afternoon, wherever you may be.
Yeah. Bill, I want to thank you for taking some time out for us and doing a webinar with us. So if you're ready to share your screen, I want to remind people that you can ask questions. Bill's here for about 45 minutes or an hour or so. If you have any questions during this live webinar, feel free to ask them. We'll take a look, or maybe we'll hold them off until the end of the presentation. And Bill has, at the end of the presentation, a really good offer and some additional resources for InterNACHI members to get some training on infrared. Bill, I really appreciate it again. So if you want to take over, thanks a lot. What are we going to talk about today?
Hey, today we're going to talk about infrared thermal imaging in the home inspection profession. And, you know, first of all, I just want to thank you, Ben and InterNACHI, for allowing us to do a webinar today. And I'm open to any questions that you may have. But we'll just look at some basics of infrared thermal imaging for property inspections. Just a little bit about myself. I've been a thermographer for about 15 years. And my thermography business actually started when I was a property inspector. I was a property inspector and a member of InterNACHI and NACHI master instructor for 15 years. But about 11 years into the inspection business, I decided to get into the infrared. And that kind of progressed to the point where my thermography business was doing quite well. The other thing that I am is FAA 107 certified SUAS pilot. So I instruct the SUAS, or if you will, drone courses for ITC, the Infrared Training Center. So, a lot of different things that we instruct: level 1, level 2, level 3, thermography, optical gas imaging, public safety, roofing thermography as well. So this, hope you enjoy this. If you have any questions, feel free to post them at the Q&A or ask them online. We have a complete training schedule, course descriptions, registration, and more at infraredtraining.com. And if you're in the Middle East or Africa, irtraining.eu is a great way to review what we offer. And the other thing that we have there is some pretty exciting promotions right now. If you sign up with a course and sign up for a specific package, it actually provides you with a E6 and a 1-year subscription to FLIR Thermal Studio. That's our latest software, and FLIR Thermal Studio is about $1,200. So this is a pretty exciting promotion with the camera and the software. We also, of course, you can get social with us at Twitter, Facebook, YouTube, infraredtraining.com at Instagram, and of course, LinkedIn. YouTube is a great way to learn as well, because there's a lot of videos there on what emissivity is, how to operate a given camera. So there's a lot of information available there at YouTube at FLIR.com. At IR Training, the other thing that you can get at IRtraining.com, there's a lot of free webinars. It doesn't have to cost money. How do I operate my FLIR EX camera? What is infrared? So there's a lot of opportunities here, and they're just free. I mean, and this is partially the way I learned as well, is to take advantage of the free webinars. So a lot of questions. Question number one is, what is thermography? You know, we call it thermography, but really, what is it? So some of our objectives today are going to be, what is thermography? Overview of where thermography may be used in property inspections, some different types of cameras, radiometric reporting. What does radiometric mean anyway? We'll discuss that. Overview of the Infrared Training Center courses and free webinars, and then of course, question and answers if you should have any questions. So according to Webster, thermography is the process of writing or printing involving the use of heat. But basically, thermography is the involvement of an individual with an infrared camera. And no matter how well the salesperson might tout that an infrared camera does it all, it does not. Without the person behind it, it doesn't work. It won't turn itself on by itself. It won't take the image all by itself, and it sure won't analyze the image for you. So the cameras are pretty remarkable today. And as Ben alluded to earlier, they're smaller. They've come down a lot. The first camera that I purchased, and that was in 1997, was $36,000. The same technology today with the same resolution, actually, and easier use of function is about 10. So things have changed a lot for thermography, and I think they've changed for the good. Remember, your camera, an infrared camera, does not see through anything. What it detects is the amount of emitted energy from the source, or the lack of emitted energy from the source. So the camera really doesn't see through the walls or see through an object. It's detecting emitted energy from the source. This is an important thing to remember as we do thermography. Why can we see something very different in an infrared thermal image that we can't see with our eyes? Our eyes can only see about 0.4 to 0.75 in the electromagnetic spectrum. Very, very narrow band. We see colors, we see faces, we see a lot of things, but the challenge is we think we see it all until we get into infrared. I know when I first started in thermography, it was very eye-opening for me to see that we could see items in the long wave between 7.5 and 14 microns, emitted energy in that long wave band. So we get to see more. And in my opinion, we get to advise our clients more as well. So our clients may have specific questions or specific evaluations that we just can't accomplish always with the visual human eye. This is a good image here taken from the outside of a home. And again, a lot of this webinar will have images, but you can see there's areas of the sections of this vaulted ceiling inside this home that may not have adequate insulation or insulation deficiencies. Again, interpreting the image is very important, and having to learn how to interpret that image has to do with emitted radiation, emissivity, background reflections, distance, humidity, ambient temperature. All those things have a bearing on the image and what you're going to see on the screen. Then it's really important to whatever you're looking at, whether it's electrical, mechanical, whatever you might be looking at, is that you have the appropriate, what I call, background knowledge and experience. So even though we may know a lot about thermography, if we don't have the background knowledge and experience about electrical, as this example, we may not be even able to know what we're looking at. And that's why I think this technology is perfect for home inspectors. Many home inspectors have been trained, are qualified, and understand building science. So being able to see moisture intrusion, insulation deficiencies, air leakages is almost a natural for a property inspector because they've been trained in that arena. This is an image I just wanted to show. And one of the images here in electrical, and this is of course an electrical image, is this image was originally said that this breaker was bad. Of course, we don't know that breaker to be bad. It goes back to, hey, what do we know about the component? So in order to determine something like this, you would have to determine the load. So if the load is 80% of the load of the breaker, an example, if I have a 20 amp breaker and I'm at 16 amps, it means that this load, the breaker is under full load. Maybe something's drawing in a lighting section or something, but on the flip side of that, if I see a breaker like this and there's only 3 amps on it, it could indicate that the breaker may need further attention by a licensed electrician. Now, just because we're doing thermography doesn't mean we provide the detailed analysis. We provide a diagnosis that's open for opinion by a licensed professional with plumbing, electrical, mechanical, whatever it may be. We're providing more data. We're not here to make a determination. And I think that's an important part in our business as home inspectors. You know, we need to follow our standards of practice. So it's important that we might be able to provide data that will lend towards a better evaluation, if you will, rather than actually providing a resolve. Another electrical image here, and I've just drawn some arrows. The thing about infrared is it's something that you would not see in the visual. If you look at the visual images here, you don't see that these wires or these conductors are hot. Here you've got on the left side, you've got a conductor at the top. And you can see that, of course, that wire is overheated. On the right side, you see a neutral conductor coming into a panel, but you visually can't see that they are overheated. Of course, this may be a good example of further recommendation by a licensed electrician. I'm going to mention just some basic ASTM standards as well. ASTM 1060 is a technical reference for use of thermography in determining insulation efficiencies. In this image here, you can see that there are some insulation deficiencies, if you will, or there's some lack of efficiency here. And this increased cooling costs, increased heating costs, and it's quite easy to see. This is what's called a qualitative infrared image. So what we're doing is interpreting the image based on our background, knowledge, and experience. You don't see any temperature measurements here. Temperature measurements, if it were on this screen, would be a quantitative measurement. So two different types of measurements, or two different types of evaluations, I'm sorry, qualitative or quantitative. So just wanted to kind of put that into the discussion as well.
And Bill, for home inspectors, we're in the qualitative, right? We're not really, home inspectors are not measuring things, moisture content or temperature differences. Unless you're in Texas, I think they actually have to measure the temperature difference at the furnace and the air conditioning system. But we're in the qualitative, not the quantitative world, right?
I would agree, Ben. I would agree. Most of what my experience has been in the property inspections is using our background knowledge and experience that we know as home inspectors and using it qualitatively. Most building science is going to be qualitative. It's rare that we would use it quantitative.
Yeah.
But then again, if we do use it quantitative, do we know the standards to take a good quantitative measurement? And that gets into more discussion than we have time for today. Another image of a qualitative insulation deficiency in a vertical vaulted ceiling. Kind of an interesting discussion here. This was a brand new construction, was 8 months old, and they could not get this room to heat above 58 degrees, even if the thermometer or thermostat was set at 80. So it was pretty interesting here that we could have helped them identify this with a simple qualitative image. This is kind of an interesting image as well. This is an insulation deficiency at a ceiling. And of course, it's much cooler on the inside than it would be in the attic. So the insulation deficiencies show up as warmer because what we're detecting is the actual heat from the attic. The second law of thermodynamics just kind of tells us heat transfer always occurs hot to cold. So that heat energy is going to be moving through an object or through a ceiling in this instance, so that the infrared camera can detect the emitted radiation from the lack of insulation in the attic. Just a little bit about SIPS panels. There's just a general assumption that SIPS panels are very tight, and overall they are. But if during the installation process, those SIPS panels are not caulked or installed properly, you're going to see some insulation or some air leakage or air intrusion. So I've just, there's a couple of temperature spots here, and we've just put them into, to show that the outside temperature is about 51 degrees, the inside temperature is about 55. We're getting air infiltration through the outside corners of SIPS panels. And I was rather surprised the first time I seen the SIPS panel installation and the air leakage that was occurring at certain locations. But just another application that you might consider. Of course, attic accesses are probably one of the weakest parts in any structure. The attic accesses typically doesn't receive the same amount of insulation as the rest of the attic. And depending on where you're living, what zone you're living in, and you can determine that by the International Energy Conservation Code, you need to apply the same type of insulation to the attic access as you would to the rest of the access. And there's different ways to do that. But this is a great area of heat loss in many structures. And many of you may or may have not have seen this, but this is just a general graph that's been around for quite a while. ASTM 1060 is a technical reference guide for use of thermography in detecting air leakage. Basically, every home has a neutral pressure plane. That neutral pressure plane could be anywhere from 3 feet to 4 feet up from the main floor that you're standing on. Anything above that neutral pressure plane is air exfiltration. It's pulling the air out of the structure. Anything below that is air infiltration. And I don't know if anybody's experienced this, but sometimes we will walk into a home and we can smell odors, or we smell maybe mustiness from a crawl space. That's because we're experiencing air exfiltration and air infiltration in every home. So ASTM 1060 is a great technical reference if you would like to consider looking into that to identifying air leakage. The other thing about air leakage is that it has a great impact on insulation. If I have an R19 in a wall and I have a lot of air leakage to that wall, I can cut that R19 down to R10 pretty quick. The other thing about air leakage, whenever we have air movement, we also have moisture molecules moving through the structure. Those moisture molecules can deposit within the walls, bring allergens with them. So it's air leakage is probably one of the biggest calls that I got as a home inspector with an infrared camera. I'm sitting and watching my TV in my recliner, and I have cold area behind me. I don't like that. If I might be willing to pay for it. I mean, it isn't about the cost, but I don't want to be cold in my recliner when I'm watching my favorite football game. So I got a lot of phone calls for air infiltration as a property inspector. This is kind of a unique image I took quite a few years ago in '06. And I actually took the IR camera up into the attic, and the insulation was, this was deemed to be a very energy efficient structure. It was a condominium. And of course you can see that probably with the block wall there, but the amount of air infiltration through the attic was pretty substantial. And this was not with a blower door, which we can talk about later, and it was not with pressurization of the structure. This was just the structure under normal use. So again, never be able to see this with the human eye, but by identifying air leakage or air exfiltration, you're able to identify a lot of these areas quite simply. This is kind of a different image too. This is a half wall basement that is half concrete and half frame structure, and air leakage is coming from where the frame structure meets the vertical sidewall. This is another common complaint that I heard or had when I was in the property inspection business, is the basement is always cold and I can't figure out where the air is coming from. You're just assisting people in identifying where those air leakages are. Again, this is another SIPS panel construction, air leakage both at the ceiling and the vertical sidewalls where they attached. So significant air infiltration like this can really change the interior of the living and cause some discomfort for our occupant or our clients. This was a access door to a upper level vaulted ceiling area. This was an access door or storage area where the door simply didn't get insulated and did not get sealed. And again, it looks extreme, but really this was not with a blower door. Again, we didn't depressurize the structure in this image. This was just natural air infiltration from the attic area. You can get air infiltration and exfiltration from a lot of different areas. Ceiling lights, outlets. There's just a lot of areas where air can infiltrate into the home. Depending on the climate that you're in, this is one of the images that I took several years ago, but this is from a bathroom shower enclosure. And bathroom shower enclosures are very difficult to insulate. They're either put in well before the insulation, or they're put in, insulation's put in, then it's sealed over it. So if there's any defects in the insulation, it can't be accessed. This person continuously had frozen water piping in their shower. They were very frustrated. So we took this image and showed it, and it was very difficult to access this and remedy this after it was enclosed. But there was obviously significant air leakage here that was causing discomfort to the clients. And usually a bathroom's quite smaller, so you feel and you notice that the floors are cold really quickly. There's also air infiltration where the tub met the floor. So when the individual walked into the room, they could feel the floor was significantly colder than other areas of the home. And it's just from air infiltration. Several years ago, I wrote a white paper, and it's called Building Thermal Envelope Commissioning with Thermography. The reason that I mentioned this is that this was a very large part of not only my home inspection business, but also of my infrared business. I worked with architects, general contractors, engineers, insulation contractors to identify insulation deficiencies in blown-in cellulose, and this is an image of spray foam that you see on the screen, and identify those prior to putting the sheetrock up. I found this to be a huge part of my business. Huge part meaning I was doing anywhere from 6 to 7 of these inspections a week. It does require a blower door, but it does help you to identify these issues prior to covering them up with sheetrock. If you'd like a copy of this, feel free to email me. at william.schwan@fleer.com. My email is at the bottom of the screen. Drop me an email, and I'd be happy to forward this to you for your review. Windows. We have to talk a little bit about windows. Of course, we know as home inspectors, windows have argon gas between the panes for insulation. When that gas leaks out, the windows can actually grow closer together. This is a good image here of what's happened when argon gas has left the seal. Energy from the outside and inside shows in an oval inside the window. And this is a good indicator that the window may not or may have lost its thermal seal long before you see any condensation. And a lot of windows are warranted. So I did quite a fair amount of work of this for people who were purchased a new home and wanted to make sure that their energy costs were maybe a little higher than they thought. And while this was still under warranty, this could be repaired by the warranty, by the window manufacturer and the builder prior to warranty. And that really assisted my clients in the costs, because these type of windows could easily be over $750. I mean, way over that. So I enjoyed working with some structural engineers as well. Structural engineers in this image would say, hey, can you kind of tell me if there is any solid object that is different than the rest of the wall that would be a column that could properly support that is there or is not there? And in some cases, if you take my arrow or the arrow on the screen here, I could even, in some cases, if it's cold enough outside, warm enough inside, I had a great enough delta T, I could tell if there was a metal support underneath this, underneath the sheetrock. So in some instances, architects and engineers really appreciate somebody who knows thermography and can assist them with evaluating these type of evaluations. Here's another evaluation that I did for structural engineers, and that is performing infrared thermal imaging on CMUs, concrete masonry units. Of course, we know when we build a concrete block wall, the structural engineer will designate that certain cells will be filled with grout or concrete. The question is, are they properly filled, and did they get filled all the way to the top? And the engineers would have me come by on a monthly basis, or sometimes every 2 weeks, and do these scans just to assist them in assuring that before we put any load on top of the roof, like a huge roof frame, that these buildings were structurally completed correctly. The arrow shows what a grout line would look like. Of course, in order to do this, we need to know a little bit about thermography and infrared science, specifically heat capacity. The grout lines have a different heat capacity than the open CMU unit. So the grout lines will hold the energy longer than the open CMU unit. So that's kind of what we talk about in a lot of our classes, is just some basics of infrared science to assist you in interpreting these images correctly. Roof moisture. Roof moisture has been performed for 20 years with an IR camera. It's nothing new. This has been, and of course, it's also being done quite broadly from an SUAS. If you're looking for a specific standard, ASTM 1153C is a technical reference for roof thermography. It can be done with an E8, it can be done with a C2. Again, this is qualitative thermography. We're not measuring the temperature. What we're trying to do is to see where moisture may be hidden under the membrane. Now you may be asking, so what does it look like? And that's why I included the image on the bottom. The bottom shows that there was not only moisture underneath the membrane, there was also moisture up into the exterior insulated finish system. And you can see that, and I'll bring my arrow down so I can kind of see where that's at. And then the roof membrane as well. So why does the infrared camera see this as warmer? Just some basics about infrared science. Water has the highest heat capacity of almost any object. So during the day, when the water beneath the membrane heats up, and as soon as the solar load is off of the membrane, you can see there's a difference in between the way the membrane holds the heat and the water holds the energy. So it makes it easier for us to identify areas that may have moisture underneath them. This was, again, a fair good amount of my business that I work with roofers. They love this technology, didn't want to invest in it, but were happy to hire me to do it. So this is another opportunity for us as property inspectors.
And Bill,
Yes.
you're mentioning heat capacity. So when if a home inspector is looking for moisture, which we love to look for, one of the things that's fairly not easy to find, but the heat capacity of water makes it a lot very fun to find for a home inspector who holds an infrared camera in his or her hand. Because the heat capacity, like you said, it's the one thing in a building that holds the most energy for the longest period of time, right?
Exactly. So water has a thermal capacitance of 1.0, very high. If you compare that to other objects that might be metal, it has a very low, or oil has a thermal capacitance of 0.80. So it looks different under the membrane. It looks completely different. Remember though, if we're in the inside of the building, people always used to ask me, hey, do you have an infrared camera? Yes. Can you come and find moisture in our walls? And I'd say, nope, but I can find evaporation.
Yeah.
They quit being smart with us and just come out and find the water, okay? But really, if it's on the inside and it's not exposed to solar load, it's evaporation that you're seeing. Evaporation cools the surface, condensation warms it. So if you have water on the inside and it's not exposed to solar load or heat, that evaporation is what you're looking for. One of the tricks I used to use that was fun is that I would do moisture mapping, and many of you maybe have done this. I would take a fan, accelerate the rate of evaporation, and find the moisture much quicker with an infrared camera because I would cool it down. Of course, this is a time thing. So if you spend too much time on it, you'd cool the object down to where you couldn't see it.
Yep.
So it's timing.
Yeah, so an entire wall or an entire carpet could be wet. If it's the same temperature as the environment, you won't be able to actually see it with the infrared because it's kind of like invisible if it's the same temperature. But because it has a hold on energy for longer periods of time, if you blow air across it, then you change the environment and it looks different. The water kind of pops out.
Great point, Ben. And if you look at ASTM 1060 or 1153, they always recommend one thing. There's a minimum 18 degrees Fahrenheit or 10 C delta T between the object that you're evaluating and ambient temperature or a similar object.
Yep.
It's important to remember, you've got to have a delta T. If no delta T, you have no heat transfer. So it's an important thing to remember. Just threw this slide in. I know there's a lot of people in property inspections are using SUAS cameras. And as a pilot myself, I find that we work with a lot of people that are evaluating 900,000, 1.5 million square foot roofs. And it's a lot faster to evaluate it from the air. Cameras have made huge improvements. And we can take visual and infrared camera images at the same time. We can do it faster. We can cover broader areas. And roofers are really looking for people that know and understand how to do this practice. Another inside moisture, again, what we're looking at here is evaporation. So evaporation cools the surface, condensation warms the surface. So moving that air creates my delta T, as Ben mentioned, and it allows me to see with more definition where the water might be. Just another image here of a moisture intrusion in a ceiling from an upper level apartment that kind of flooded. I like it when people say it's a minor flood. There's no such thing as a minor flood. If it's a flood, it's a flood, is my opinion. But IR is going to let you see to the degree how far did that moisture really move. It even works at the exterior of the building if the conditions are correct. This is a leaking wash machine valve at a second-story apartment that obviously has traveled down through the inside of the wall cavity and is visible from the outside as well. One of the things that we don't think about using IR for is plumbing. We have a plumbing trap or a plumbing area that is has a blockage. Where's that blockage actually located? Is it down further up into the pipe, or is it the bottom of the trap? This is real easy, and the reason it's easy is, again, this is qualitative. It's qualitative because what the camera is seeing is real basic. More radiation or less radiation. The blockage has a different ability to emit the energy than the rest of the pipe. So you're seeing a difference here. More emitted radiation, less emitted radiation. Of course, we haven't talked about emissivity yet, and we'll talk about that briefly as well. How hot is the water temperature? Again, something that's pretty simple with an IR camera, as long as we remember it must be in focus. If your camera is out of focus or the image is out of focus, with an infrared camera, with a regular camera, if our image is out of focus, it looks distorted. But with an infrared camera, not only will it look distorted, but all of our temperatures will be wrong. So we need to make sure that our camera is in good focus in order to take a temperature. This is a quantitative image. This would be one of the few examples we'd use as using the camera quantitatively. Another example of quantitative, although it could be qualitative, is radiators. We look at a radiator, we can see that there's a difference in temperature, and there could be a partial blockage in this radiator that is not allowing the full flow of the fluid through the radiator. Inflow radiant heat. Of course, this is region specific, but if we are looking at inflow radiant heat, here you're seeing a perfect design and layout of an inflow radiant heat system. Looks quite well. And here you're not seeing that. And here you can see that the lines are not spaced correctly. You can see that their lines are overlapped. This was a rather interesting project and a brand new home construction. And a lady said, when I stand in front of my refrigerator, the floor is always cold, but if I move 2 feet, it's nice and warm. What's going on with that? So we did this evaluation, and of course there were several issues, but we think this might be something that's very simple, but really it wasn't. The beautiful cherry cabinets all had to be removed. The floor had to be removed. All the appliances had to be removed. They were well over 180,000 before this was complete, because it was a very large kitchen area. So you think it might be something quite simple, but there was a demand that this be fixed and made correct. So IR can help us identify some things. HVAC. Here we see some HVAC leakage. This is in a basement. You can see the support, unfinished basement here. We've got some air leakage here at the connection points. This is a rather interesting one I took in a crawl space. Notice that there were no heat distribution, and when the heat was running, there's very little airflow through the grills. So looking down on the crawl space, what we found is during the installation process, the end never got put on this duct. So all the air that was being produced by the furnace unit was being blown directly into the crawl space. And we see a little bit of air leakage up here at the top as well. How about beehives, termites? Pests can be seen as well. Pests generate energy. And if that energy is different than the rest of the wall or the rest of the component, you'll be able to see. Here's a good example of two different resolution cameras. Image on your left was taken with a 320 by 240 resolution camera. Image on your right was taken with an 80 by 60. The higher the resolution, the higher the number of pixels, the more detail we achieve. So you can see the graininess in this image, and you can see a little bit more clarity over in this image. But pests are sometimes can be easily seen as well. One of the new products we just came out with, and Ben had mentioned he likes his C2, and so do I enjoy mine. We just came out with a new camera called the C5. The C5 has a 160 by 120 resolution, but the major change here is there is cloud storage for all the images. So you no longer have to store the images in an SD card or offload them. You create a cloud storage unit or storage for all of your images and can access them anytime for you or your client. So there's a lot of different applications from HVAC to anything where the C5 or the C2 is a great camera. And I've used one for years. I carry one in my back pocket almost every day. So it's just handy because you never know what you're going to get into. Other different types of cameras might be the FLIR E8. The FLIR E8 has been around for, oh gosh, at least 8 to 10 years. It's tried, it's been dropped, it's been thrown, it's been fallen off ladders. I'm just talking about my personal experience. But the E8 is very durable, and it has a good resolution of 320 by 240. The E75 is a newer camera, and the advantage of the E75 is that it is all touchscreen, and that the focus can be manually focused, where on the E8 it is auto-focused. So you get a little bit, you get better detail, easier use of function. And then the T cameras, the T530 is again, just another step up. The lens can articulate 180 degrees straight up or straight down. And I've found this to be very useful in property inspections, electrical inspections, overhead power inspections. One thing that I try to look at is to look at the highest resolution that I can afford, along with how productive can I be with the camera. And I kind of learned that the hard way. I started with a typical handheld camera, and then I was asked to go and as a property inspector, start doing electrical substations. Well, I found that didn't work. So I had to graduate and move up to a new camera. So try to look 5 years down the road when you're thinking about buying an infrared camera, because they're literally, the new warranties are 2 years on everything on these cameras, no matter what goes wrong with them. 5 years on any battery. So the battery starts to not hold a charge, they'll simply send you a new one. And 10 years on the microbolometer. So these cameras are designed to last much longer than the first camera that I bought. So I think you're going to see better ergonomics, more productivity. And these are all things you might want to look at if you're going to look at a camera.
Bill, I remember watching some videos of drop tests from FLIR. They would drop the camera on a platform or something like that and try to damage it on purpose. And so they're really durable. And I've dropped a few of mine too. Samuel asks, I heard 320 by 240 is a pro standard. What about the pixels? What is a pro level for pixels? Or maybe what's a recommended minimum?
You know, for property inspections, if we're going to, if you want a real professional image, it's the 320 by 240. And that's basically 76,000 pixels. The reason that I mentioned the 320 by 240 is, let's say that I get a call that that says, hey, I'd like you to look at 17 electrical substations. And I've got the journeyman electrician. You don't need to make any determinations. We just want somebody that understands thermography and how to take the image. The 320 by 240 is a great utility resolution, which means I can use it on almost any application. I'm not limited to just property inspections, just qualitative. So the 320 by 240, in my opinion, is a camera that can span a lot of different applications. So the other resolutions, of course, would be 640 by 480 and 1020 by 960, which is usually used for overhead power because we can't work at close proximities. We have to have distance between 345 kV. So I hope that helps answer your question.
Yeah. We've got another question too. We're Facebook, we're YouTube Live, and we have a question. Can you discuss the differences between the higher end models and the lower end model, like the FLIR TG267? And you kind of mentioned the benefit of buying something that you may want to grow into in the future, like a building inspector or a home inspector may want to get the minimum low entry cameras, and if you're going to expand your business, maybe invest. And there's another question, what is the what would be a great entry level camera without breaking the bank? Jonathan asks, like a FLIR E5 XT price range. Maybe you can go over about that one more time. What should a home inspector buy, and what do you think about the differences? And the FLIR TG267, I'm not familiar with that.
The FLIR TG is a handheld device with a very small screen that's about 1 inch by 2 inches square, and it is primarily used to look at something qualitatively to say, is it hot or is it not? For example, a lot of electricians, especially overhead power electricians, everyone has one in their bucket. They pull it out and go, yep, it's still hot. I'm not touching it. I thought it was supposed to be locked out. So it's a safety camera or it's a safety device. But if you ever need to measure anything, the simple answer is the sensitivity is not there. And the margin of errors for measurement are quite large. So the other thing is that you're not going to get a very wide field of view. So if you invest in an E5 or an E8, you get a wider field of view. You can measure with those much easier. And as far as home inspectors, my answer to this is look down the road 5 years, Ben. And that's kind of what I had mentioned before. The E8 may satisfy what you're going to do 5 years down the road, but make sure you have a resolution that you won't regret.
Yep.
And the TGs are going to have a resolution that's very low.
Yeah. Like the FLIR C2, the one I really like. Michael asks, for someone just starting out, what camera do you recommend? Money's tight, so you have to be conscious about costs and overhead and investment. So I recommend, you may disagree, Bill, like if you can get into infrared at a low cost, decent camera, that'd be a good first step, but always be improving, always starting to think about investing into something bigger and better. What do you think?
No, I agree, Ben. And the biggest mistake I made is I bought a FLIR B camera. I paid $3,800 for it. It didn't work after 9 months for the applications I had coming in. So I sold that for $1,000. So in 9 months, I lost $2,500 basically. If I were to review that again, I would say, maybe if I invest a little bit more, I'm not talking about a lot, but a little bit more, such as a FLIR E8 right now, I think is $1,800 or $1,700. If you look at the C2 camera, it's 625. So I'm going to have to invest $1,000 more money, but will it take me 4 or 5 years down the road?
Yeah.
You know, that's the question we all have to ask ourselves. And, you know, people all the time ask me, hey, do I need to spend $11,000? And the answer is, hey, no, you don't. You can get a great camera for under $5,000 today.
Yeah.
That will get you started in the business for, you know, a few years down the road. I have some other questions coming in. Do we want to answer them now or at the end?
Well, Michael asks, you know, so where do you use an infrared camera in a house? I don't know. Everywhere you're looking, I guess. For me, I would look where I would think we have a moisture intrusion issue on the inside of the home, and or home energy deficiency area. Those are easy ones. Anything that's you think is hot, maybe an electrical device, switch or something, that would be another one. So maybe those 3 areas. What do you think, Bill?
You know, I agree. If we're going to be property inspectors, of course we are. We're going to move the electrical dead cover or the electrical cover off the panel. A quick scan can tell you if something is overheating at electrical connection to a breaker or to a neutral wire. The other thing I always looked underneath shower pans. So if I'm in the basement and I see there's a shower upstairs, a shower on the second level, I noted the proximity and I gave that a quick scan, because that is also a potential area for water leakage. Underneath cabinets, I loved it to scan underneath cabinets. How about refrigerators? Every refrigerator's got a water hookup to it. I would scan the floor in front of it. Not only would I scan the floor in front of it, I'd scan the wall behind it if there's an adjacent hallway behind it, because these are all areas of potential water intrusion. Sometimes you can just scan a flat ceiling and go, hey, you know, there's an area there that just simply has a probable insulation deficiency. So when I do get in the attic, I can pay attention to that area. So it helps you in many ways. It also helps your client.
And on YouTube Live, we have some questions about training. Different kinds of training that's available. There are many, there's several other training classes and levels and online and live. I think you and I would agree that no matter what training course you take, I'm sure you prefer the ITC training. You got to get a camera in your hand, right? No matter what class you get to get it into a training class for sure, before you even think about using an infrared camera, and then make sure that training involves getting a camera in your hand.
You know, I agree. Basically, here's the bottom line. We want to do the best we can for our clients. The worst thing we can do is give them bad data. And, you know, whether it's a property inspector doing an infrared survey, that's the worst thing we can do. Different classes. Level 1 thermography is a 3.5-day course. And that course gets you into quite a bit of detail about several different applications, including property inspections, so that you understand how to, number one, interpret the image, how to measure correctly. Let's say I don't want to take a 3-day course, so or 4-day course, I'm sorry, but I want to take a simple 2-day course. We have a wonderful 2-day property inspection course specifically for home inspections. And that's a great 2-day course to get you right into the basics. There's a 12-question exam. And at the end of the exam, you get a certificate of completion just to show that you have some basic background and experience. The other thing is that if you want to just go onto our webinars are chock full of information about what is emissivity. They're free. There is no cost, zero cost at infraredtraining.com. So you can go get the information for free, say, hey, I want more, take the 2-day class and say, no, I want to go all the way to level 1. And the difference between level 1 ITC and level 1 other courses is we follow the American Society for Non-Destructive Testing guidelines for certification. So no matter where you go globally, your certification is valid. You can go to Germany, you can go to Puerto Rico, and that certification is still valid. So that's kind of why our training may be a little bit different.
Very good, very good. There's a couple other questions that are highly technical maybe, and you know, for further information, you know, that Bill's always available. And somebody asked for your email address as well. So please continue with your presentation and we'll get to the questions later.
Great. I've got a few answered questions here too. We'll continue, and we're just about wrapped up here.
Okay.
Remember, if you're going to take infrared images, you have to analyze those images. In order to analyze those images, you need what's called radiometric software. Well, what is radiometric? Well, first of all, radiometric software is that every pixel contains a temperature. So radiometric software would be FLIR tools. And guess what? It's free. So you can download a free version where you see it on the screen there at FLIR.com/product/FLIR tools. It's free download, and there's no hooks or connections. You don't have to upgrade it. If you want to upgrade it, you can, but you can keep that forever. I mean, and there's no annual fee for it. So it's free, literally free. So this is a great way to thermally tune your image or take a look and analyze your infrared images. We also have a product called FLIR Tools Plus. The advantage of FLIR Tools Plus is I can take 6 images horizontally or vertically in thermal, and I can stitch them together and analyze all those images. So if I have a large commercial structure, 10 stories, I can stitch all those things, those items together, all those images together. And I have more analysis of those images in FLIR Tools. FLIR Thermal Studio is another advanced, is much further advanced, so I can take video, I can edit video all thermally, extract images, put them back in. FLIR Thermal Studio is a lot more detail and a lot more to analyze. Remember, when you're doing a property inspection, several things you might need, including, it includes IR too. Your moisture meter, anemometer, what is the wind speed? Wind speed will cool the outside subject area or cool the component, maybe making it difficult to see. A blower door, of course, some of us may or may not be familiar with this. This is pressurizing or depressurizing a structure to assist in finding air leakages. We can use mirrors, but the most important thing I think we have to remember to use is our background, our knowledge, and experience. And personally, I've never been afraid. If I don't have the background, knowledge, and experience, I'll hire somebody to assist me. I'll be happy to do it because they're going to help me learn that subject matter. So I've never been afraid of hiring someone. Don't forget to market it. With the ITC certification, you get the right to market the ITC logo. A lot of people put it on their websites. They use it to market, and it drives business. Buyers, sellers, attorneys, engineers. I did business with all of these folks, both in thermography and in the inspection business. So they're looking for folks that can help them with thermography. Limited time, there's no limit on this, really. Sign up for any infrared training course at www.infraredtraining.com. Use the code NACHI20 and receive 20% off any enrollment. So whether it's the 2-day course or the 4-day level 1, maybe you want to take an SUAS course and learn how to evaluate roofing from the air. 20% off any of our courses. You can view all of our courses at infraredtraining.com. I just want to say thank you to everybody that listened in today. Greatly appreciated. I know you may have a few questions. I know there's a few Q&A questions. Is it a good time now to try to answer those? Samuel Lopez, what was your email address again? I would say that the best one would be william.schwan@flir.com. william.schwan@flir.com is the best email address. Another question that came in from Paul. Do we anticipate having an RCT class in Boulder anytime soon in the reasonable future?
Well, what's ITC doing with classes nowadays during this COVID thing?
Yes, we'll be doing live classes again. beginning June 23rd, I'm doing a class in Denver for optical gas imaging. So we'll be going live with our classes. Of course, we'll have limited attendance, only 9 students per class to start with, social distancing and everything else involved. We do have a level 1 online course. You take the first day on your own, and there are 3 days of instructor-led course and with an examination at the end. So there's also that ability, if you wish. In our online courses, we have had over 500 people sign up already. So our online course will also expand to level 2, optical gas imaging, and also to SUAS.
Let's see. What camera do you suggest that combines IR image and photography side by side? Don't they all do that? They have, doesn't all the FLIR ones kind of combine or put them in picture in picture?
Lewis, a great question. Yes, all cameras today, all the infrared cameras today will do picture in picture side by side. So first thing it'll do is take an infrared image. Within 2 seconds, it will automatically take the visual image. So you always will have 2 pictures side by side.
Paul asks, what should electrical circuits be under load to get a proper evaluation? You kind of mentioned that a little bit before.
Oh, Paul, great question. Great question. If we're talking about indoor power, it should be a minimum of 30% to load. So if we're not at a minimum of 30% to load, we won't see enough resistance from the system. So most of them should be at 30%. If we're doing outdoor power, it's 40% load.
David asks about building science course. Does ITC have a building science course?
We do have a building science course. We still have that course. We have had limited enrollment, so it's still out there. It's still available. We'll post that in the schedule, and you can see that schedule at infraredtraining.com.
Does does FLIR have an infrared drone?
Yes. Yes, we have several infrared cameras. FLIR started about 8 years ago, actually, with infrared cameras on SUAS. And the latest one is actually the Mavic 200.
Yeah.
Mavic 200. And that has a 640 by 480 resolution camera on it.
Wow.
And so it's very good resolution camera. And it, of course, takes visual and infrared at the same time. So I was actually out just flying out last week. And of course, we've got several cameras. We've got the FLIR View Pro. The FLIR View Pro is actually probably one of the most reasonable cameras. It comes out with 640 by 482 for $1,500.
Wow.
You can attach that to several different types of platforms or aircraft. So there's also called the FLIR Duo. The FLIR Duo gives visual and infrared at the same time. Again, 640 by 512. And that camera's come down considerably in price. It's well under $4,000, I believe. But there's a large opportunity out there for SUAS as well. I know there was a question, I think it just disappeared. One of the questions was, I had a P65 camera.
Yeah,
still a
dinosaur.
Very valid camera. And I said, and absolutely, that was the one I paid $336,000 for. That P65 is a very, very durable camera. It's still out there, 320 by 240 resolution. So yes, I love that camera. And I did applications from overhead power to substations to indoor electrical to building science to just about everything with that.
Well, Bill, I really appreciate it. Really appreciate your time being with us and talking infrared. It's one of my favorite topics. I'm a big believer that all home inspectors should be carrying a really good flashlight, an infrared camera, moisture meter, and all that fun stuff. It only makes them better inspectors. So I really appreciate your time talking to us about infrared. And I know if there are any more questions, you can contact Bill, and I really appreciate it. Thanks, buddy.
Thank you, Ben. It's been a pleasure. Bill Schwan, and drop me an email if you just want to talk, or if there's any questions you have at william.schwan@flir.com. Thanks, Ben.
Right. Thank you, Bill. Stay safe and healthy, everybody. Bye now.
Bye-bye.